In this video, I'm going to go over how to find the derivative of an inverse function. And I'm going to start out with showing you the concept. We're going to start out with some functions that we know the inverse of, and we're going to look at the relationship between the original function's derivative at a point and the inverse function's derivative at a point. All right, so let's start out with f of x is equal to x squared, which does have an inverse if you limit the domain x greater than or equal to 0. And we could find the inverse of that function, we would get root x. All right, so let's look at the values 1, 2, 3, and 4. Well, if I plug those into f of x, I'm going to get 1, 4, 9, and 16. Okay, so now let's take the derivative of f of x, and we can do that easily, and that would equal 2x. All right, so now let's evaluate those at the x value. So we would plug in 1, we would get 2, 4, 6, and 8 as our derivative values. Okay? All right, now let's look at the inverse. Now remember, the inverse of x squared, we're going to take the output values of x squared. Those become our inputs. So we're going to go 1, 4, 9, and 16. And now we're going to plug those into the inverse, which is root x. We would get 1, 2, 3, 4. So we would flip those around. All right, so now what's the derivative of root x? Well, that would be 1 over 2 root x. Okay, now let's plug in the x value to see what the derivative's value is at that point. So we would get 1/2, we would get 1/4, we would get 1/6, and we would get 1/8. Okay, so now what we're doing is we're looking at the relationship between f prime and f inverse x. Okay, so take a look at the table there. All right, let's try this with another function next. Okay, let's try it now with f of x is equal to x cubed. So the inverse function would be cube root of x. So what we're going to do is we're going to do 1, 2, and 3 as our x values. So f of x would be, in this case here, 1, 8, and 27 when we plug it into x cubed. The derivative of x cubed would be 3x squared. So that means if we plug in x, we would get 3, we would get 12, and we would get 9 times 3 is 27. Okay? All right, so let's flip around. The output now of f of x would be the input for the inverse. So our 1, 8, and 27 go here. Cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3. Okay, so now what is the derivative of the inverse? Well, that's x to the 1/3 power. So that would be 1/3 x to the negative 2/3 power, which is the same thing as 1 over 3 times the cube root of x squared. Okay, so what happens when we plug in x equal 1 into that? Well, in the first case here, we get 1/3. If we plug in 8, we would get the cube root of 8 squared, which would be 4, so we would get 1/12. And then if we plug in 27, the cube root of 27 is 3. 3 squared is 9. 9 times 3 is 27, so we would get 1 over 27. So what I want you to do is I want you to look and see the relationship between the original function's derivative value at a point and the inverse. Okay, so hopefully you can see the pattern there where it is the reciprocal. All right, so let's do some problems using this concept. Okay, we showed in the last couple examples this relationship between the original function's derivative with the x value plugged in and the inverse is derivative with an x value plugged in. So in general, let's let f of x be a function that is both invertible and differentiable. We're going to let y equal the inverse of x for all x satisfying f prime of f inverse x not equal to 0. So the derivative of the inverse would equal 1 over the original function's derivative with the inverse value plugged in. All right, so let's go back to our f of x equals x cubed and f prime x equal to 3x squared. Let's look at the point 5, 125. Well, we know that f prime 5 would equal 75 if we plugged in 5 into the derivative. We know that f inverse of 125 has to work back to 5, right? Okay, so in general here, the derivative of the inverse with 125, so the derivative of this would equal 1 over f prime, in this case here, 5. Okay, because our output value of 125 is being plugged in to the derivative here. So we'd get 1 over f prime of 5, which is 1 over 75. Okay? So what I'm going to show you in the next example is why we have to use this, because a lot of times we're not going to be able to get the inverse directly of the function. So we have to use the original function's derivative in order to get our answer, and that's what they'll do a lot on the AP test. All right, let's use this concept. Given y equal x cubed plus 7x, let's let x equal 1 and find the value of the derivative at that inverse point. All right, so we know in this case here that y prime is equal to 3x squared plus 7. So y prime of 1 would equal 10, right? Okay, well, if we plug in 1 into the original function, we get the output value of 8. That means that y inverse of 8 has to equal 1. So that means that the derivative of y inverse at the value 8 is equal to 1 over the original function's derivative value at 1, which we know is 10. So the answer here would be 1/10. Okay, let me show you another way of doing this in the next example using implicit differentiation. And this would be another way that you can find this. Okay, so here is another method that I've used before with teaching this. We can do this with the traditional swapping of the x and y values and then doing implicit differentiation. So in this case here, we're going to take the original function and we're going to switch the x and the y. And then what we're going to do is we're going to do this implicitly left to right with respect to x. So the derivative of x would be 1. This would be 3y squared dy dx plus 7 dy dx. We're going to factor out a dy dx. So we'd get 3y squared plus 7. So that means dy dx would equal 1 over 3y squared plus 7. And then what we're going to do is we're going to take our inverse point. So we know the point on the inverse would be 8, 1. So we're going to plug in the y value and we would get 1/10. So that is another way that I have taught it before. The AP is going to kind of use the concept of the original function's derivative, the inverse, and I'll show you when we do some AP problems later, but this is another way to do it. All right, let's try this example. We're going to let f of x equal x plus cosine x. We're going to let g of x represent the inverse of f of x, and we want to find g prime of 1. Okay, so if 1 is going into the inverse function, we need to work backwards and figure out what x value in the original gave us 1 as our answer. And now the AP will do this a lot, especially on the non-calculator. They will give you something where it's easy to plug in an x value to figure out what the answer is. And usually it's a 0 or a 1 or a negative 1. So in this case here, I can see that if I plug in x equals 0, I'm going to get 1 equals 0 plus cosine of 0. Well, the cosine of 0 is 1. So that I know in this case here in the original function, f of 0 is equal to 1. Okay? So that means if I want the derivative of the inverse, it's going to be 1 over f prime of 0, okay, from our rule. All right, so the only thing we need to do is figure out what f prime is and plug in 0. So in this case here, f prime x would equal the derivative of x is 1. The derivative of cosine x is negative sine x. And if we plug in 0, we get an answer of 1. So we plug in 1 here. So we get g prime of 1 would actually equal 1. Okay, so I'm going to finish the video with an AP-like problem. This is from the 2007 AP Calculus AB test, FRQ. And we're given a table of x values with f prime, g, and g prime. It says if g to the negative 1 is the inverse function of g, write an equation for the line tangent to the graph of y equal g inverse x at x equal 2. All right. So the first thing we need to identify here is that if I want at x equal 2, that means I need to figure out what g inverse of 2 equals. Well, in order to do that, I'm going to go look up where on the table where g of x is equal to 2. So I see on the table that 1, 2, so in other words, g of 1 is 2. So that means that working backwards, g of inverse 2 has to equal 1. So that means the point I'm going to use is the point 2, 1 when I write my tangent line. Okay? So what do we know about the derivative of the inverse? Well, it's going to be 1 over, so we know our slope is going to be 1 over, and in this case here, g prime of 1. Okay, so we go to our table, g prime of 1 is equal to 5. So our slope is 1/5. So that means our tangent line when y minus 1 equals 1/5 times x minus 2. Okay, so I hope that helped you learning how to take the derivative of an inverse function. I try to give you multiple examples, and we finished with an AP here. So if you liked the video, please like and subscribe. Thanks for watching.